Hello class, this is going to cover chapter 8. It's just going to be kind of an introduction that I want to use, and then in class we're going to cover more of the actual problems to these. So we're going to be covering markups and markdowns and gain some insight into perishables. Also, we're going to be looking at break-even analysis. The slides weren't actually, they were too short. They didn't cover what actually the book covers. So one more thing to add to this is break-even analysis. So yeah, we'll be talking about markups that are based on cost, markups based on our selling price, markdowns and perishables, and then we would have another learning objective 8.4 that talks about break-even analysis. Let's go over some of the terminology that we use here. So the cost is referring to the price that retailers pay to the manufacturer or suppliers. So you're a company that sells pins. The cost that we're talking about here would be the cost that you incur from purchasing them from another company. The selling price then is what you are selling them to the customer, whether that is an individual or a business. So if you're a wholesaler and you manufacture in large quantities and sell to someone, say like Walmart, another company, that is the selling price. You to Walmart is the selling price. Cost would be what you pay to get the supplies and make those pins. So our markup, margin or gross profit, kind of all the same thing and same idea here. So it's the difference between the cost of bringing the goods into the store and the selling price. So how much did it cost to get them to our store, and then how much did we sell them for, and the difference between that would be our margin or our gross profit there. Operating expenses or overhead expenses. So it's the regular expenses of doing business, such as rent, wages, utilities, some other things in there, but these are what we would call like fixed costs. They don't change. We are going to have these costs if we produce one pin or if we produce 100,000 pins. These are our operating costs that it costs just to run the place for a month, would say. So then our net profit or net income. Net profit, or it's the profit remaining after subtracting the cost of bringing the goods into the store and our operating expenses. So after we've figured out the difference between our cost and our selling price, or also called our gross profit, so we take gross profit minus our operating expenses gives us our net profit. Basic selling price formula. So this formula, S equals C plus M, or selling price equals our cost plus our markup. Okay. Again, we can manipulate this in a lot of different ways, and we've seen how to do that many times, right? If I want to solve for markup, I'm going to subtract cost and put it on this side. So it would be selling price minus cost equals markup. And we can maneuver that way for what we need to solve for. So here's a quick example just to kind of get you going here. So if we have a selling price, remember our selling price is what we're selling it to our customers for. So if we're going to try to sell it for $1,200, so that means it, and we bought it for $900, then our markup would be $300. Okay. So our cost plus our markup are $900 that it costs to bring it to our store. Then our $300 covers our operating expenses and hopefully make a profit here. We're trying to make $300 on top of the $900 gives us our selling price of $1,200. And whether that $1,200 is a good price or not will be determined by, the market, right, if we're selling it or not. So let's now get into some of the calculations. how do we determine what our prices should be? What should we pay for items? All this is real important into making it as a business. So markups based on cost. Again, cost is what we purchase our materials for. So let's say, so in this problem we have cost, again, is always going to be 100% in this case. We want to mark it up 33%, so our selling price would be the sum of both of these numbers, or 133%. Calculating dollar markup and percent markup on cost. So let's look at an example here. Target buys Levi's jeans for $18. So Target's buying these jeans from some other company for $18, okay? And they want to sell them to you for $23. So what is Target's markup? So let me write a little here. So they rearranged our selling price formula, right? So selling price equals our cost plus markup. So they rearranged it to solve for what we wanted to solve here. What is Target's markup, right? They rearranged the formula to solve for it. So we have our selling price was $23 and we bought them for $18. That means we had a $5 profit from those. So how much is that in percentage terms? This is dollar terms. Now we want to know what is his percent markup on cost. I think they meant to say what is Target's percent markup on cost. So the percent markup then is the dollar markup, which is this, our selling price minus our cost, divided by how much it cost us, $18. So 5 divided by 18 is 27, or roughly 28% that we're making on one pair of jeans. This is a check. So if we have our selling price equals our cost plus our markup on the cost of the goods, remember the cost of the goods is $18 and we marked them up 27.78%, which is $5. So 18 and 5 is 23. So yes, we did that problem correctly. So let's calculate the selling price when you know the cost and percent markup on the cost. So we know how much something will cost us, and we know how much we want our desired profit that we want to make. So he wants to make 65% above and beyond what it costs to buy this refrigerator. So our selling price equals cost plus markup. That's our formula. So Ray's Appliance bought a refrigerator for $100. So again, that's our cost. To make a desired profit, he needs 65% markup on cost. This is important to pay attention to. What are we marking up exactly? That's what we're going to have to multiply our markup percentage by. So it's 0.65 times our cost price, or 100, equals our selling price, right? So let's bring this out a little more. 100 plus $65, right? He's wanting to make, on a $100 refrigerator, he wants to make $65 above the cost. So the selling price then equals $165. So that's what he's going to try to sell it for. So he's going to look around, Ray is, and he's going to say, yeah, no one else, I'm at a good price. Everyone else is selling relatively close to this price. I can make my markup, so I'm going to keep going with this company or this business here. So let's calculate cost when you know the selling price and the percent markup on cost. So Jane's imported flower business sells floral arrangements for $50. To make her desired profit, Jane needs 40% markup on cost. So what do the flower arrangements cost Jane then? And what is the dollar markup? Right over here. So again, our selling price formula, selling price equals cost plus markup. So Jane imported flower business sells flower, so she sells them for $50. Sorry about that, my phone. She sells them for $50. To make her desired profit, Jane needs a 40% markup on our cost. Okay, so our cost is, well, we don't know our cost yet. That's what we're trying to, that's what they're asking us. What do the flower arrangements cost? We don't know. But we do know that the markup equals 40% or 0.40 times our cost that we don't know yet. So we're still calling that C. So let's work this out a little. Oops, sorry, this should be 50 equals 50 equals C plus 0.4. All right, so that's a point there. So we have like variables here. We have a 1 C, right? If there's just C by itself, that means there's 1, and we have 0.4. So we have 50 equals 1.4 C. We want to get C isolated by itself, so we divide by 1.4 equals, on this side it's just going to cancel out, but divided by 1.4. So these cancel. We're left with just C on this side, and 5 divided by 1.4. $35.71 is the cost. So then they ask, what is the dollar markup? So back into our formula, selling price equals cost plus markup. So selling price is 50 equals our cost plus our markup, which we don't know, we're trying to solve for. So we subtract, we take 50 minus 35.71, 14.29 equals our markup. So that's solving for cost when we know the selling price and percent markup on cost. So markups based on selling price. So we were just doing markups based on our cost, right? When we were multiplying our markup times our cost price, whether we knew it or not. So now we're going to be talking about markups based on our selling price, or what we sell them for to customers. Same formula, right? Selling price equals cost plus markup. So calculating a dollar markup and percent based on our selling price. So we have a Target buys Levi's jeans for $18. They plan on selling them for $23. What is Target's markup? And again, we found this earlier, it's $5. 23 minus the $18 it cost us is $5. So what is Target's percent markup on the selling price? All right, let me go over that again. I was reading that and it doesn't look right to me. So they're saying the percent markup on selling price they're asking, but yet they're showing percent markup on cost. So that would not be correct here. So we want to see the percent markup on selling price. So our problem then is we're still going to be over $5, but instead of the $23, oh no, they did it right. I'm sorry. They did it right. They just have the wrong wording there. Equals 21.74%. That's confusing me. We'll cover that more in class there. Calculating the selling price when you know the cost and percent markup on selling price. So Ray Appliances, again, he bought them for $100. To make a desired profit, he needs 65% markup on the selling price, not on the cost this time. So what is Ray's selling price and the dollar markup? So I kind of like to write it out. Our selling price, our markup, and our cost. So our selling price is, we don't know. Our markup, he needs 65% markup on the selling price. So we don't really know the selling price in dollars, but we do know that it's 65% of the selling price. Our cost is $100 again. So let's plug it into our formula. So S equals C plus M. S equals 100 plus point, I'm just going to do it right here. 0.65 times S is 65. 0.65S. Solve this a little more. We have 0.65S minus 1S over here. Leaves us with 0.35S equals 100. I want to divide by 0.35 to get the S by itself. Divide by 0.35. Divide by 0.35. These cancel. We're left with S equals 28571. So they're saying, what is Ray's selling price? That's his selling price now. So we know his selling price. 285.71. So what is Ray's selling price and the dollar markup? So we know the selling price. Let's plug it back into the formula. 285.71 equals our cost, 100, plus our markup, which we're going to solve for. Subtract over 100. 185.71 equals our markup. So now, instead of having this variable as a markup, we know it's 185.71. So let's calculate the cost when you know the selling price and the percent markup on the selling price. So Jane's Imported Flower Business sells floral arrangements for $50. So our selling price equals 50. To make her desired profit, Jane needs 40% markup on selling price, right? Kind of important. Markup equals 0.4%, 0.40, right? On the selling price. And our cost equals we're going to solve for cost, so we don't know. That's a question mark. So let's plug it into our formula. Selling price equals our cost plus markup, 0.4 times S. 50 equals C plus 0.4 S. Let's subtract let's The selling price we know, right? 50. Let me erase this. We know our selling price, so let's plug it in. Our selling price is 50. So it's 0.4 times 50. 0.4 times 50 is 20. So let's isolate our C. 50, take 20 from it. 30 equals our cost. So what is the dollar markup? The dollar markup is here. So the dollar markup we solve for is right here. Our 40% times our selling price, that's the dollar markup on the selling price, $20. And then they cost us $30. So this is a kind of a quick formula way to go from markups based on cost to markups based on selling, and then markups based on selling and converting that to markups based on cost. So you can use these formulas here to go from one way or the other. So if you know your markup based on cost and you want to say, well, what is that converted to our markup based on our selling price, you can convert it. So in this case, they have markup, percent markup on cost is 27%. So they plug it into the formula as percent markup on cost divided by 1 plus the markup on cost is 21. And then they just went the other way over here with it. One thing you'll notice when you're going from, that's actually on the next slide here, when you're going from a markup on the selling price to a markup on the cost, it's always going to be more because the selling price is always going to be higher than the cost, so that the difference between the two will give you a different markup here. So we've talked about markups. Now let's talk about marking things down. You would mark things down. We're trying to get rid of something. So let's take, for example, if you had shirts that say, 2013 on them, and it's December 2013, you're probably wanting to get rid of them, so you're going to mark them down and try to just get rid of that inventory, at least to make something on them instead of lose all. So markdown percent equals our dollar markdown divided by our original selling price. So Sears marked down a $50 tool set to $36. So what are the dollar markdown and the markdown percent? So dollar markdown cost us $50. We're selling it for $36. 14. Sorry, I wasn't really, kind of lost track there. 14 bucks. So we're $14 off, or in percentage terms, we convert it to percentage terms. Dollar markdown, 14 divided by the original selling price, 50 equals 0.28, or 28% markup. So pricing perishable goods are goods that go bad. So Sue's vegetable stand, she grew 20 pounds of tomatoes. So Sue expects 15% of the tomatoes to become spoiled and not sellable. The tomatoes cost her 50 cents a pound, and she wants a 75% markup on cost. What should Sue charge for each pound of tomatoes so she will make her profit? A lot going on here in this problem. So we need to know the total selling price. We know the difference is here we have not just one unit, but we have 20 units here that we need to work with. So we need to find this total selling price and total cost and total markup. So the total selling price equals our total cost plus our total markup. So our total cost, the cost that we incurred for growing 20 pounds of tomatoes. Down here it says the tomatoes cost her 50 cents per pound. So 1 pound to grow costs 50 cents. So our total cost then equals 20 times 0.5 or $10 when you work it out. So to grow this 20 pounds, it cost her $10. Okay. So then our total markup then is she wants to make 75% on the cost of them. We just determined the cost to be $10. So she wants to make 75% above that. So now let's plug it into our formula here. They've already done it. Let me show you. So our total selling price equals our cost, $10, plus our markup, which is 0.75 times she wants it based on cost. So our cost is $10. So this comes out to 10 plus $7.50, right? So our total selling price then equals $17.50, as you see here. So in order to make her profit of 75% that she wants on the cost, using 20 pounds of tomatoes that she grew, she needs to sell a total selling price for all of them $17.50. Okay. There's a problem though, because these are perishable goods and they're probably going to go bad, some of them, by the time she actually sells them. So she's saying she expects 15% of the tomatoes to become spoiled. So now we need to remove that 17% from the pound and then get our per tomato price that we need, or per pound that we need to sell for. So we have 20 pounds. She expects to lose 15%. So she expects to lose 3 pounds of tomatoes, or now she's only going to have a total of 17 pounds to sell. She still needs to make this profit margin, or this total selling price. She still needs to make a total of $17.50, and now she only has 17 pounds instead of 20 to work with. So we're going to take the $17.50 per the new pounds equals 103. So it takes her, now she needs to sell each pound for $1.03 in order to make it, given that these are perishable items. So now this is what I've made up that they didn't have in here to start with. This is our break-even analysis. So we're going to talk about some fixed costs, variable costs, selling price, contribution margins, and our break-even points. So let's real quick. Fixed costs are costs that don't change. Our rent, wages, usually to employees, stuff like that. Variable costs that do change. It costs you, we'll see, 80 cents to make one pin. So for every pin that you make, it changes the cost, the total cost that it costs to make them. So 2 pins, $1.60, and so forth. The selling price then is, we're looking at it from the manufacturing side of things. How much does it cost to make that they have to sell them for as a bulk item to make it. Contribution margin is the difference between the selling price and the variable cost. So we can sell them for $1. We have variable cost of 80 cents. So we have a contribution margin of that one pen of 20 cents. Break-even point, the point at which the seller has covered all expenses and costs. So we know it cost us, or we know that we have expenses of $60,000 a month, and how many pens do we need to sell in order to get to that 60,000 just to cover the expenses? And hopefully we have sell more to get above and make a profit. So let's calculate a contribution margin. So contribution margin equals our selling price minus our variable cost. Okay. So assume Jones Company produces pens that have a selling price of $2 and a variable cost of 80 cents. Calculate the contribution margin. So the contribution margin equals selling price $2 minus our variable cost of 80 cents. That leaves us with a contribution margin of $1.20. So each pen that we produce cost us 80 cents, but we can sell it for $2. That leaves us with $1.20. So each pen provides us with $1.20 of profit that we can use to pay for those expenses of operating the company. So now calculating a break-even point. How many of those pens do we need to sell given our contribution margin of each pen in order to cover our expenses of being a company? So the break-even equals our fixed cost divided by our contribution margin. So Jones Company produces pens. The company has a fixed cost of $60,000 a month. We'll say $60,000 a month. Each pen sells for $2 with a variable cost of 80 cents. So how many pens do you need to sell to cover your expenses? So our fixed cost, 60,000 divided by our contribution margin, which is $2 minus 80 cents, which equals 60,000 divided by $1.20. Which equals, I had to turn to the right page there. So 60,000, how much it costs to run our operations, and $1.20 per pen we get. So that means we have to sell 50,000 pens just to cover our expenses. And so every pen beyond this 50,000 pens, which equals $60,000 a month that we're bringing in, so every pen beyond that is contributing $1.20, and so $1.20 in profit that we're gaining in excess of our expenses. So that's it for chapter 8. We'll cover more of this in class and do some more of the examples.